get started. So yesterday we were talking about solving yesterday we learned how to do word count and other problems using Spark. So now let's take a more practical example whereby we would try to compute the max temperature per city. All right. So let's say you have a CSV file. This CSV file lists the temperature of each city, right? This is the temperature. First column is temperature. CSV means comma separated file. The columns are separated by comma, while the records are separated by new line. All right. So the objective of this exercise is to find out the temperature, the max temperature per city. So any suggestions, anybody?
Was group
Yeah.
by city and then sort by the city.
Okay. Okay. And in terms of Spark, that's the right way to think. All right. Okay. Hiten suggests that we could use reduced by key. Is that your suggestion, Hiten? Okay. Okay. All right. So I think that's what Muhammad also meant. And anybody else? Okay, a question from David is, before we start, was the table created for Spark data frame versus Python versus SQL? Not yet, not yet. But I have created the project that we discussed yesterday regarding handling the binary files. All right, so that we'll discuss today. Okay, but I'll try to do that maybe by the next week. It's good that you reminded. Okay, it's good that you reminded. And also, let me just create my notes so that I can just review those notes at the end of session. Today's date is 22 April. Okay, so 22 April 2018 BDHS. All right, now, great, great. So, all right, this is in my to-do. A question from David is there a GUI for coding instead of command line interfaces? You can definitely use the Jupyter Notebook. Okay, you can definitely use the Jupyter Notebook. Also, you can definitely use the IDEs such as say Scala IDE. Okay, so there is an IDE called Scala IDE. Using that, you can download that and install it. So the IDEs are not available. The GUI is not available on the cloud, but you can definitely install on your machine and then do the programming there. Okay. And since we are dealing with analysis of big data, and every analysis is generally done in an interactive way. Okay. So whatever processing we do, generally we do it in an interactive way. That's where the Jupyter Notebook or the console plays a very, very important role. While we are building larger projects, then we use an ID like Scala ID. Otherwise, we do it from the command line itself, right? So you could try this one. And if you go to say my courses, okay, if you go to my courses and inside here, you will notice there is something called writing Spark applications like this one. Okay, actually you can start working with that right away. Okay, after this session. So you can start working because this one does not require any other thing. The knowledge of Apache Spark Key-Value RDD is sufficient to start working with writing Spark applications. All right, good questions. So, all right, let's get back to the problem that we were showing.
Sandeep, there's one question like previous. Today my colleague asks, where is the Hive table stored in? Either it will store in the Oracle database or in HDFS.
Okay. Okay. So yeah. So Hive table is something like we discussed as part of Hadoop. Hive tables are stored in Hive Metastore. Hive Metastore is generally stored in the usual databases like MySQL, Oracle, Postgres. It depends upon the configuration. In our case, Hive tables are stored inside MySQL.
So it can be stored in HDFS also.
No.
It cannot be stored. So it needs some database.
Right. So basically, there are two parts to Hive tables. We will see it further when we talk about Spark SQL. Every table has got two parts. One is data, other is metadata. Metadata means table name, columns, and the definition of the underlying data. That format, along with the columns description, this is stored, the format as well as this name definition of columns is stored in where? In the relational database. Okay, that one is called metastore. So metastore can be configured to be stored in MySQL, Postgres, or Derby, as Raju is suggesting, and so on. All right.
Okay, thanks.
Okay, great, great. All right. A question from David is: so, is there a way to load the code from a file? Yes, of course. You can just say Spark Submit, and then you can load the code from the file. All right. And you can generally use SPT, right? We discussed earlier about SPT, and where we basically build a project using SPT. This we are going to do at later point of time, David. And right now we want to do an interactive analysis. So you could take a look at, in the meantime, I would strongly recommend you to take a look at writing Spark applications. This one, this would definitely give you a fair bit of idea. And this actually caters to your question. So it has 16 steps, but you can actually skip a lot of these steps and directly jump here. Okay, just take a look at this. So for everyone, after this session, you should take a look at this, the writing Spark applications. Okay, we'll also walk over it once. And the second one, you should take a look at the Spark project. Okay, Spark project. Also, in this, I have added one of the exercises to this one, the Key-Value RDD. I've added the exercise to this in the last. All right, this one. So these are the things that you must take a look at post this session. Okay. All right. So these are the three things that you must look at, because mostly when you are doing installation, it would take time, and this project, these pages would help you in resolving those issues. Okay, so these are step-by-step guides in order to set up your own environment and in order to do the project and exercises. All right, so these are the three things you must take a look. All right, so let's get started. Right, so let's get back to the question. Question was that if we are given a CSV file, which is a plain text file, where the records are separated by new lines and the values of each record are separated by comma, the question is, how do we compute the max temperature per city? Okay, one suggestion was to use the reduce by key. All right, so let's take a look at this. All right, so first of all, we are going to use a file in the folder called Spark /data/Spark/temps. Okay, I'm going to log into the console. Okay, I'm going to log into the console. Instead of Jupyter, I'm using my SSH. You can also use that, but it's completely okay to use either the Jupyter terminal or using the web console. Okay, so we have to find the max temperature per city. So let's take a look at Spark Shell. Okay, so question is we are given a file called /data/spark/temps, right? So let me just show you how does the file looks like. If you go into say my lab and click on Hue, you can take a look at this file. Okay, you can take a look at this file by going to file browser and /data/data, then /spark. And then /temps. So this is the file that contains the records. My question is, how do we find the max temperature per city? Okay, so this is the file that we are looking at. Anybody? Okay. So first of all, we are going to load this data as one record per line. Okay. Then next thing we are going to do is we're going to write a function called clean record. And then max. Okay, let me walk you through this code. Zoom it out a bit. I'm just allowing everybody to record. All right, great. So let's get started. So here, first of all, we are loading the data from here, right? Then we are writing this, we have written this function called clean record. Okay, so let's get started from here. So, okay, so at this point, we have txt RDD that should have our record. So let's take a look at 5 records from it. Okay, so you can see that this is an array of 5 values. Okay, now if we want to take a look at say 0th record, say first record, this is the first record, and so on. All right, so we are able to see that it has loaded this whole thing as a single string. Okay, this is a single string. Now further, what we do is we write this function called clean record. Let's take a look at what it does. So if we had a string like this, the clean record would basically break it into the city and the temperature. Okay, how does it do that? First, it breaks the record by comma, and then it trims the values and also converts the temperature into integer. So it returns a tuple. This is the tuple this clean record is returning. It contains only the name of the city and the temperature. All right.
Why do you have to trim it to remove the extra pieces?
Yes, correct.
But then why did you not do it for the 0th record?
0th record, because when we say to int, I think it generally cleans it up.
All right.
Okay.
Okay. I think it's the beginning, so there will be no extra pieces before it.
Yeah, but there could be. It's a valid
Oh, there
find. So ideally we should. Okay.
All right. Thank you.
All right. Does it make sense? So a question from Hitendra is array 0 forms the key to the RDD. This becomes the key to the RDD. Okay. So now let's call this function. Let's call this function. Let's call this function. I'll just copy paste this code to you so that all of you get the code and can do it together. Now, next thing is the function we just checked. We just checked this clean record function. It seems to work perfectly fine. Now let's call this function on the RDD. And how do you call it on RDD? By using the map. So what it's going to do is it's going to convert this RDD, txt RDD, each line into the record. Okay, into the record. You can see it has converted the data into the tuples. All right, next one is we are defining a function called max. This is our local function in Scala. We can check if it's working or not by, say, passing 5 and 6 and 51 and 6. So it's working perfectly fine. It's saying the way we are written is if B is greater than A, return B, otherwise return A. All right. So now next step is use the on the records RDD, we say reduce by key. And what will be the key? Key will be the city. Okay. And then we are passing the max function that we have just defined. Now let's take a look at the result. Since the data is really small, we could just say collect and we will get the records. Okay, we'll get the record. So you can see that out of this data that we have in here, the outcome that we have got is this. Okay, so let me just make note of it here. All right, now let's take a look at this. So we have Chicago 21, BLR 23, and Seattle 25, right? And NYC 24. So even though no comparison has happened for these because there's only one entry to the data, while for NYC there are multiple records. Okay, so this is what we wanted to do a hands-on with. All right, the same can be applied even on enormous data, and it would work perfectly fine. Next question is from David. So how would we add the date to the result? Good question. Good question. Question is, if we are having reduced by key here, right? And we would like to find out what was the date on which the temperature was maximum, right? Any suggestions? Anybody? It's a good question. It's a good question. Let's say along with the max temperature, we would like to find out the date. All right. We would like to find out the date of max temperature. Anybody? Correct. Correct. So suggestion from David is split the string and bring it along. Exactly. Exactly. So the way we are going to do is the value, we are going to make it a tuple. Okay, use tuple to store temperature and date. Perfect. Perfect. So let's try to, who will try to write it along with me? Okay, take this code and copy paste it in Notepad and try writing it along with me. Okay, so we loaded this data, and next thing we do is in here, let me just copy paste these records so that we have a clear picture of what's going on. Okay, this is our data. Okay, so yeah, so this is our data, and the first column is the temperature, second column is the city. All right, a question from Rajan is, if I have this code in the file, how do I run it? You can simply say Spark submit and pass this code along. I'll show you, don't worry, don't worry. All right. All right, so let's take a look. So here what we have is this temperatures file. We are loading that here. Now we are defining a clean record. Instead of earlier one, we are passing the temperature as well as the city. Okay.
I actually have a question over here.
Not city. We are going to take the data along. Yeah, go ahead.
Like why we don't need to write the max function, I feel. We can simply use the sort by function.
We can use the sort by function.
Because
Okay.
once you group by the city, then you simply sort by the temperature.
Okay,
And
then.
you take one.
No,
If you
what we have to do, no, the problem statement is that we are given all the cities with all of the temperatures of every date in the history. Okay.
Correct.
What we want to find out, so for every city, for every date, there is one time, right? For every city.
Right.
Now, and there are many dates. So what we want to find out, what was that date for each city when the max temperature happened?
Yeah. So once you do group by city,
Group by
correct?
city, perfect, perfect.
Then you do sort by temperature in the descending order.
But once you do the group by, right, reduce by, the data was not there. The date was gone, right? We did not keep the data along with us, right? We
No, so
only
now
kept Chicago and the temperature and so on, right?
correct, got it. So here in the clean record function, you also include this array of 2.trim. This will keep the
Yes,
correct.
yes,
But now
yes.
if you do the sort by, I think then it should work. If you do sort
No,
by temperature.
so still we have to do we have to only pick one record, right? Max temperature record.
Yeah, so once you do sort by, you will have your records in the descending order. Then you
We will
just do
have the sort if we sort by the temperature, right? So
yes.
the whole data will be ordered by the temperature, not by the city. Okay,
Correct.
right? Therefore, again, we'll have to scan it.
All
So
right.
we could have done this way that we sort the data based on the city, then based on the temperature in the descending, right? But that we could have done, you know. So if we combine NYC with the temperature, okay, because when we do reduce by key, for each city, for each max temperature, we can find out the date. Okay, but then again, it wouldn't work out that way. The easiest one is we basically keep this extra data along with us while we are computing the max temperature.
Okay.
Okay. So because if you think about it, let's say this is our key, right? We make this as a key. Still, it wouldn't work out correctly because all we want to find out is we want to find out that max temperature, max temperature. Okay. All right.
All right.
Great. Great. Now let's say we have a twist in the story. If we have the max temperature on multiple date, we want to find out what was the most recent date on which we got the max temperature. All right, let's say that's the statement. So we could actually code it in the same way. So here, all we need to do is we need to redefine our max function. Now for max function, we will get the tuple. Okay, we will get the tuple as the argument. Okay, so tuple of string, integer, and string, right? Because when we group by data, the values are going to be of the tuple data type. So max will get tuples instead of integers as it was getting. Okay, so we'll have to write the function like this. We have to say max is comparing two tuples. Earlier it was only comparing integers. Now it is comparing two tuples. Okay, now let's try to write this function. Has anybody written the function? Not yet. Okay, Hitendra, your approach is right. Any suggestions at this point? All right, so we got two tuples, and what you want to do is if t dot underscore one, t dot underscore one is greater than, let's say equal to t1 dot underscore two, then compare the string. Okay, let's say we are comparing if the date t dot two equals t1 dot two, right? Um, return the max of the two. Okay, return t, else, oh sorry, I'm writing the Python code in between. Okay, so all right, so this is the kind of code we'll have to write. Let me just make the window bigger so we get the clear picture. If this is okay, if this is greater than this, and here we're going to put another bracket. If this is there, all right. So all right, sure. So we have great. Now what we are trying to do is we are trying to say if t1 dot t dot underscore one, right? Otherwise, return. So if both are equal, and else if, okay, somebody help me with the syntax. Okay. All right. Does it make sense to you? Let's try. I don't know if it will work or not. We need to define the data type, and the data type is a tuple of this. A suggestion from Raju is correct else if. Okay, so this is one, this is another, So I think this has to go in here. So we are saying if both the temperatures are equal, then check the city. Okay, check the time date and return the one with the bigger date. Okay, and otherwise, else if t dot underscore one, and if the yeah, this one needs to be corrected. Thank you so much. Let's just test it out. Okay, let's just test it out. So say we are calling it on 1 and 1 and say say 1 dash 2. Okay, that is all right. 1 dash 1 dash 2018. Okay, and we're calling it on say same as this. So it should ideally return 2018. Correct? Sorry. Yeah, this is wrong. We just have to put brackets here. Okay. All right. So it has returned us the second value. Had the first string been bigger than the second, it should have returned the first one. If the temperatures are equal, it's returning the bigger date. Okay. All right. And of course, the date comparison is wrong because we are comparing the strings. Ideally, we should convert it into date and then compare the date properly, right? But for this example sake, we are testing it out. Now, if this was 10, okay, then all right, it is returning this. And if this was, let's say, 100, it should return this value. All right, so our code seems to be functioning correctly. This code is functioning correctly. Now let's take a look at if this would work out. It says that there is a type mismatch. We found that it takes the intent string. The reason is we have not applied this particular function yet, right? All right, now let's try. I think it should work now. Wow, let me just again try to define my function, clean record, and then we're calling the clean record. And here we are not returning anything. So yeah, we are returning actually. Okay, here, what is it that it returns? It returns string, and then tuple of intent string. Correct. That's okay. Let's just try calling the max function. Now it's working fine. And let's take a look at this. All right. So it has found the temperature in say NYC. The 24 was on which date? It was on 2016, 2016, 5 and 05. All right. So it's a very good question. All right. And trust me, this is generally when I ask this question, the one that I asked you, the max temperature question, the way I start the interview is that given a big file containing only the temperature, give me the max temperature. There the user will do simply reduce. Okay, then I'll ask that, imagine that the data contained the city name along with the date and give me the max temperature per city. If that works out, then third question will be this, that give me according to the recent date. A question from right? A question from, let me just take a look. A question was, what if you want the oldest date, right? All you need to do is, the, okay, all you need to do is just change this function to return, instead of returning T, return T1 here, else return T, correct? You still want the max temperature, right? Or you just want the oldest date? Great. All right. So let me, Alok's suggestion is that could you explain the max function again? Of course. So what does it take? It takes two arguments, T and T1. Both are, both are, let's say you want T and T1, okay? And both are tuples. And the first value of tuple is integer, second value of tuple is string. Where did this come from? This value that you see, while returning, we were giving out tuples. Tuples were the values, and max temperature, since it's going to be called via reduce, it will get all these values to be reduced to something. The way earlier this was just an integer, now it is a bit complex object. It has a tuple. Earlier, the arguments to max temperature were int and int. Now it is int followed by string, right? Earlier, whatever was your data type of the value, that was what being received here as part of max. Okay, these values are being reduced by max for each of the key. All right, so here what is it that we are trying to do? We are comparing, first we are comparing if the temperature is equal. In that case, return the bigger date. Okay, return the tuple with the bigger date. If otherwise, return the tuple with the bigger temperature. That's what we are writing. Is it clear now?
Yes, Sandeep. This
Yes.
P dot underscore T1 underscore, this is a tuple of, can you explain?
Which one? 35 line?
Yeah, 35 and 36. Yeah.
35, 36. So what does it mean? This T is what? How many arguments does max has? How many arguments does max have? 2, correct? And what is the data type of each one of these
Tuple.
arguments? Tuple, correct? So T is one tuple, T1 is another tuple. So we are saying the first value of first tuple should be, if it is equal to this, the first value of second tuple, meaning these two are equal, right? Then compare the dates. Okay.
Yeah.
All right. And otherwise, if they are not equal, then check if T1, the T1's temperature is bigger than T2's, T's temperature is bigger than T1's temperature. And if that is so, return T, because that is the one which is having bigger temperature. Otherwise, if none of this is true, then return T1, correct?
Sandeep, why are we comparing the dates here? If the
Right, right. So I said an additional question to the main one. Say
Okay.
additional to the main question. First, what we did was we said that we want the dates along with it, right? That was easier. Then we did not need this particular condition, right? What if we said that if the temperatures are equal, let's say there are max temperature occurred on more than one dates, then
Okay.
give me the most recent one.
Okay.
All right.
Okay. Thank you.
All right. So a question from David is that this is confusing because of the variable name. Please update to temperature, city, and date. Yeah, that could have been better, right? We could have just here, instead of saying variable array, we could have just said variable temperature, city, and so on. Okay. So we could do that. And here the T1, you could have said T0 and T1 or T1 and T2. That's completely okay. All right. So also here we could have, okay, here I can't do much about it because I have to access the tuples. So I can't make it much user friendly. All right. A question from David is, what if you want both max and min temperature for each of the date the temperature occurred? Good, good. So we can actually write another min function, just like we have written max function, and we could call these two like reduce by key along with that. Okay, or let me just think of it. What will I do? What will I do? Okay. Question is, what if I wanted min and max both? Okay. What if I wanted min and max both? Who can answer this?
I think you have to define another function just like max,
Okay.
which will be called min, and then all
Okay.
the ifs will be reversed because you want the minimum one.
Okay.
For the max, you're fetching out the maximum value. For the minimum, you'll have to do like just reverse the ifs.
Okay. 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 So, all right. All right. And great. Great. I'm just thinking of an alternative solution. Okay. So yes, if we did what you're suggesting is, if let's say there are two ways to do it. Okay. The way Muhammad has described, let's say we have def min, and we define our min function just like this one, the one that we have done above, right? We could have said this like this. Okay. We could do min, and this is result one. Now we could find the output equals result dot say union of result one, right? And then we could say output dot reduce by key, and here we will just concatenate max and min. Okay, we'll just define a function called concatenate min and max. Okay, and so on. So concatenate the two values of min and max and so on. Okay, both min and max is going to be the tuple with the date and everything. So we could just concatenate that. No? It's a hard question. So yeah, we could give it a try. So all we are doing is, this is probably the simplest one. I can think of a couple of more ways to do it. All right. And one of the simplest ways is that we find the min, we find the max. So min and max both are basically going to have the same kind of a key. And once that is done, right? So once that is done, what we are going to do is we are going to concatenate this. And then since both of them have the same key, we can basically group by, reduce by key after unioning. And then based on this concate max min, we will basically be able to do that. Okay. All right. Great, great. I would leave that as an exercise, or we can take it offline. This is a very good question, and this is worth trying it. All right. Did I miss some of the questions? All right. David, did you get the approach, the one that I was describing? So this is a pseudocode, the one that I've just written. Okay. The previous one was more complete code.
Sumit, I have a question here. So if a text file has like n number of records, so the reduce by key of max we are passing, right? Will it be called n number of times?
Reduce by key, come again, if we are doing?
If you have a text file with a number of records, like 100,
Right, right.
so I'm little bit confused here. How will the map and reduce by key functions get called?
Okay, okay.
Because here we
Oh,
are calling on the text RDD dot map of clean record, right?
right,
So on each line, it is calling the clean record function.
right. This one, a clean record is being called on every line of the input,
Okay.
and then the data is being sorted and then sorted, grouped, and then reduced based on this function.
Or even the reduce by key happens on each line, right?
Right. Each key, reduced by key, would happen on each key, and this function, max function, is going to be called on every value for each key.
Okay. Then how will the two tuples get passed T1
So
2
these are two different RDDs, right? Then we are saying that we will union it. And then after unioning it, we will do reduce by key. All right?
And I mean here def max, right? I have T1 two parameters I'm passing to.
Okay, okay, okay.
Here I'm not understanding here.
All right, all right. So this is basically a pair, right? So let me ask you chain of questions. So your question is that this is not clear, right? Max
Yes.
function.
Go
So
ahead.
the purpose of max is to give out a tuple which has the maximum temperature, right? Which has the maximum of the two. Out T or T1, whichever is having bigger temperature, will return that tuple. In case both of them have equal temperature, then return the tuple with the bigger date.
Yeah,
Okay,
this logic I understood, Sandeep. I mean the passing, how are we passing the parameters to this function?
right, right. Then this, you mean 46 line? It's not clear.
Yes. How are we
Okay,
passing two values to that?
right. So if you take a look at the records RDD, what does it have? What does it have? The records RDD has these tuple of tuples. Okay, so this records RDD would look like this. Okay, the records RDD is going to look like a big array. I'm going to put a square bracket just to signify arrays. Okay, like this, right? And this one has, say, that this, so first one is the name of the city, correct? This is NYC, and then there is a tuple inside it, and here there is a temperature, and here there is a date.
Correct.
Okay. So if you take a look at this one, and the same thing will be, let's say here also, we will have, say, NYC again, and another tuple, which signifies, say, 21, and it is on, say, 212018. Okay. Now let's say we have another tuple here. Let's say this is called Seattle, right? Okay, and here the value is a tuple, correct? So some date is there. Okay, so this is how the records RDD looks like.
Okay, I
Okay,
got it. Okay,
so
okay. On these things we are the reduce by
right.
keys.
So yes. So when we reduce by key, what happens is, for this key, these tuples will come together, right? These tuples will form an array after grouping. So after grouping, this is how it is going to look like. So this will become like this, right? So for NYC, the the values are going to be an array of this tuple and an array of this two, right? Correct? So this is how you can think of it. Okay. And then for Seattle, we will have only one. So the Seattle, it's going to look like just one element in the array, right? This is how after grouping looks like. Then when we apply the max is going to be applied on this and, sorry, this tuple and this tuple. These two tuples are going to be compared. All right. If there were more than two values, then the logic will be applied at two values at a time, again and again. All right.
Okay, I got it. Oh, okay. This is per city, right? Okay, we are
Yes.
return.
Yes. Okay. So the max will be called, and what we'll be left with is something like this. What's the maximum out of it? We will be left with this. Okay. And here, since there is only one value,
Yeah,
max is not going to be called, and the resultant is this. Okay.
okay, now I got it.
All right. I hope this is clear to all.
Thanks, sir.
Okay. A question from Alok is that I'm getting this result. Yes. So that's correct, right? After we do max, this is how it should look like. So it is sorted by temperature, right? No. So here, just take a look at this one. It is basically sorted by the city, right? This is sorted by the city, not city as in it is basically the key values are not really sorted here. All we are looking for the max. We are not sorting anything. Okay. Why should it be sorted? The temperature? Yes, max for one city.
Okay, okay. I thought like it should be like sorted first. It will come max temperature.
Ah, I see.
Then like that way. Okay.
Okay, okay.
So you are saying if for one city, if multiple record is there, so we are
Yes.
getting for that city is max temperature for the day.
Correct, correct.
Okay.
All right. A question from Vidya is what is NYC 21? Right. So here I'm just taking one example here, Vinta. Is that your question? So this is supposed to be this answer, right? 2016505. That's right. All right. I will go back to. There's something wrong with the result after. Result one is this. Okay. So I think this is correct only. If you see Chicago 21, Chicago 21 at this date. BLR 23, and this is correct. And Seattle remains same, while NYC is max temperature is 24, that too on this date. So I think the answer is correct, Binta. I'm just looking at your answer. What do you think is wrong? I feel that this is completely okay. All right, so this is a very interesting exercise, and I'm glad that we did this. Okay, and I was just talking about the another approach for this one. I'll just take it out from here. Okay, and all right. Okay, a question from Vidya is the temperature should be 25. 25 is for Seattle, not for NYC. So what we're looking for each city, what was the max temperature that has been in the history, and what was that time, the most recent date in the history. All right. So did I make sense, Binta?
Sandeep,
Yes.
can I go ahead one time again?
Yeah, go ahead.
To find the minimum and the maximum, the approach that I was suggesting If you remember, I was saying group by city first, correct? So
Group
all,
by city. Okay.
which is like reduced by city, correct? Reduced
Yeah.
by key.
Reduce by
So
key. Okay.
my key is going to be New York, and the tuple, the value will be the tuple for
Okay.
New York, correct? Because it is reduced by key.
Just a second. So you're saying that after reducing by city, what will you get?
I'll get New York and then followed by the tuple, only for New York.
Okay, just like what we did here,
Yeah, correct.
right?
But now
So
I said that
you are saying the clean record will be like this.
clean record is okay over here. This is just to fetch the values out from the table.
Okay. Okay,
Then
wonderful.
you call reduce by key. You get
Right.
the same way that you've put New York followed by the tuple.
Correct.
But after this, I suggest calling sort by key
Okay, sort by key.
so that
So sort by key. So the data will be ordered by cities.
no, once you call reduce by key, it is ordered by city. And I want
Okay.
to chain an operation with reduce by key. I want to
Okay.
chain reduce by key with sort by key.
Okay.
So in New York, for New York, all my records are sorted again based on temperature.
Okay.
So if your sorting is in the descending order, your maximum is first and your minimum is the last.
Okay.
Then you just take out the first record, which is the maximum, and the last record, which is the minimum.
Okay. Okay.
That's
yes.
the that I was looking at.
So how would you order the values for each key?
Can you say that one more time? I didn't get that.
So what you're saying is you will group by the city, correct?
Reduce by key, yeah, which is city.
Right. Now for each city, what do you have as the value?
For each city, I want to do it by temperature, only for the tuple.
Okay. Okay. Why don't we do this way? You try writing a code for this, and then that will be more meaningful way of discussing. Right.
All
I
right,
would love. Right. Give it a shot, and you try writing it, and then we can analyze the answer.
Sure.
All
Okay,
right.
fine.
Okay.
Okay.
Great. Wonderful. Wonderful. A question from Rajan is, and in your maxim function, line number 51. Okay. There is yeah. So it is basically internal return. Return is implicit. That's correct. And Binta's question is, we want to find out max temperature for each city. Yes. Okay, we want to find the max temperature for each city respectively. Correct. All right. Question from David. I have tried and running into problem. Can you work the example? So I would love to take it offline and probably let's do it over the discussion forum. I would like to right discussion like you can come over. I would love to answer it there. Maybe a lot of other people would love to see this answer. So come over. It's definitely worth solving the problem. And yes. Okay, so I've given the link. Come over. I would love to solve it because it would take some time. It'll take me around 10 to 15 minutes to solve it. So it'll be better to do it offline. All right. Great. So we did two problems. We actually solved three consecutive problems. Where one was finding the max temperature per city. Then we did the max temperature per city along with the date. Third thing we did was we only picked the most if the date temperature for max temperature has occurred for a city twice, then we pick only the date which is most recent. All right. So this way we were able to do sophisticated operation using RDD. Such kind of operations become difficult when we are dealing with, say, SQL or even Pig. Even in Pig, I actually could not solve such problems. I so well remember once somebody gave a project from Society General, there is a bank, and they were having a similar issues. And the mechanism of defining tuples and so on is actually quite convoluted in case of say Pig. So it was difficult to handle even even a bit of complexity there. All right, David. So let's do that the problem over the forum. I would love to answer, and we will do we will work the example. So most likely your solution could be very close, and it will be quite easy to work offline. All right. A question from Raju: can we direct to Spark to put specific data in one particular partition, like in this case, all the temperature related to a specific city in one partition? Good question, Raju. No, we cannot cherry pick the data based on the particular key, a particular value, and put it in a particular partition. No. All we can do is we can order the data. We can order the data and expect the partition to work with the ordering. All right. So we can't really cherry pick that this key goes on this partition, this key goes on this partition, but we can definitely sort the data and repartition the data. All right. We will talk about repartitioning at a later point of time. There are multiple kind of schemes of repartitioning. We will take a couple of examples of repartitioning. All right. So we can have our own custom repartitioning, and we'll talk about it after a while when we discuss about the advanced operations. Wonderful. So there were a great set of questions. So I hope this is clear to all of us. Right? So is this, should we go ahead?
Hi Sandeep, this is Alok.
Yes, go ahead.
Sandeep, just one thing I am trying to understand. Like once we call the reduce by key, so
Yeah.
when it is passing to the max function, the two tuples, it will take the two tuples by the same key, not the different key.
That's right.
When it is getting the from records RDD,
Right.
so record RDD have the city name with the tuples
Right.
and the same key name, and then so it will take the max function, it will pass the same key first in the reduce
No,
function.
correct. Correct.
Okay.
So in this example, you can see the diagram.
Okay.
So here, for each key, the values are being grouped, and then this is where your function is being called. Here we are summing it up. If we were calling max, first it'll compute the max of 2 and 3, then it'll be 3, 3 and 6, the answer will be 6. Okay.
Okay. Thank you.
So for the max function is being called for each of the keys separately. All right, great. So Bintao, David, Alvin, Alok, Bharti Raja, Grisma, Hitendra, Mohammed, Prasant, Rajan, Raju, Ravi, Robin, Sachin, Subbu, and KRK. Should we move ahead to the next topic?
So Sandeep, our course is going to into the next week, or it will go beyond the next week?
There are going to be at least 6 to 7 more classes.
Because I got the today mail like your lab is going to means ending in next week.
It'll be extended, don't worry.
Okay.
Okay.
Yeah.
Great. So let's get started. All right, so those were basic key value operation. There are some more key value operations which are a bit complex. And all right. I'm just waiting for everybody's answer. So should we move ahead? Yeah, some of you have not responded. Okay. All right. So let me just try pasting the code.
Sandeep, can you commit that file, this text file?
Okay, actually this one is not here. Let me see if I could just upload from here. Okay. CloudxLab. All right, Spark and examples. examples. All right. Maybe I'll just commit here.
Yeah.
Okay. All right. So I can just drag this file. Okay. Okay. So I have committed it there.
Thank you.
Did it work? Yeah, it is there. Great, great. So we were able to do really complex things easily using the. So those who are looking for this file, they can download from here as well. All right. The remaining one will be difficult to commit. I'll do it again after this. Now moving ahead and here. So now on the key value RDD. Although whatever we have studied earlier, flat map, map, reduce by key, map, and so on, those functions can do almost everything. But there are few more functions that you could find useful. Let me give you the slides so that you can all use that. Great. So let's move ahead. So we learned the problem solving with this Spark so far using either key value RDD or normal RDD. And we also learned Scala so far as part of the Big Data with Spark course. So, and we also did the basic understanding of the Spark ecosystem, and we did the hands-on with various tools. All right, now moving ahead to a little bit more advanced key value RDD operations. One of them is keys. Keys essentially give me only the keys. Okay, so it'll pick the first value from each tuples and give the answer. The values give only the values, no big deal. Group by key is something a bit of crazy. It groups the data based on the key, but it's an action. And how should I say? So it's not an action, it's a transformation. So group by key groups the data based on the key, and all of the values are together. Now, if the values are really humongous, then you're going to have hard time processing such kind of RDD. All right. So group by key is generally used when you are not able to reduce the values together, and instead you want to say apply a for loop to process the records. Okay. There are many functions, that you cannot apply reduce on. Right. So let's say you're computing something like something that cannot be distributed, something that's not commutative and you're commutative and associative, so you can't really write a reduce function. In those cases, what you can do is you can group all the values together and then do apply map or flat map so that you will get all the values for a key together, and you can process that linearly instead of parallelly. Okay, so that's what we are trying to demonstrate here. So let's say we did the group by key, it brought all the values for each of the key together, and then we can process the data using the iterator. Okay, we could collect will bring it locally, and look when you bring the data locally, then you can iterate over this. Here it's going to first group the data based on the keys. The vals will be a key value pair collection, the array, and then for each of them we will access for each of the I, we will access the product iterator and iterate over it. So for each key and for each values, this is what will happen.
So Sandeep, it is a list. So where it is mapped key value.
What? So when we parallelize a list of tuples, automatically it becomes an RDD of key-value pair.
Okay, that is a map.
Yeah, map. No, actually, here this is a list of tuples.
Yeah.
And the RDD of tuples is a key-value RDD is nothing but a kind of an array of tuples internally.
Array of list, we can say.
Array of tuples.
Okay. It is a list.
So we are converting this list, which is in-memory list. This is a list of tuples, right? This is a list of tuples. We're converting this list into an RDD. Now this RDD will have how many keys? 1, 3, 3. So 3 keys, correct? And for each key, it'll have that. So this will be, there'll be 3 elements in this RDD after we do sc.parallelize, and each of the element will have these key values, right?
Yeah.
Make sense? No. So take a look at it. Try doing it together. It's completely okay to do it together while we are talking. So you can say rdd.take 1. Okay, we are saying that give me only 1 record. So it gave me a local array, right? This is my local array. It has only 1 element. So it has only 1 element. Okay, and that element is this. So we can say this is 1 and this is. Do it make sense to you? So this RDD, when we say take 2, okay, is going to give me an array of tuples. Okay, this is that array of tuples. So you can see this. So you can say, give me, say, first element from this array which we brought, and then this is a tuple. On that you can operate. All right, do it make sense to you? So it will basically, a list of tuples will become an RDD of key-value pairs. All right, here, what we are trying to do is, we are trying to do groupByKey. Okay, groupByKey. Let's take a look. So we are saying RDD1 is groupByKey. Now take a look at the data type of RDD1. It's a key is integer and the value is iterable, meaning value is going to be like a cursor instead of the whole thing. To avoid the memory overflow, it basically creates the iterable so that we can iterate on the one value at a time. Okay, that's how the most of the iterators work, and that's how the cursor pattern work. And if we take a look at, say, first element of this one is going to return me an array of one element. This is the data type. Okay, so compact buffer is nothing but like a list of things. Okay, list of things. If you take a look at, say, first 2 elements, we will take a look at it. So here, since there are 2 keys with two keys with the value 3, therefore those 2 tuples have been brought together. Since there are 2 tuples with the same key, therefore those values are brought together. So you can take a look, and when we say collect, all of this comes locally, and then we can iterate over it. And the way we generally deal with an iterator is by using the product iterator. So we can iterate over any iterable using the for loop. Okay, using the for loop. So, okay. So let's say we are iterating over the values. Every value, when we are iterating like this is our handle to iteration. We could actually get the value of this one using product iterator. Okay, the value is going to be another array, and so we are iterating over the value. Okay, so whenever we are writing anything, we could always access the product iterator, meaning the value along with that.
I have a question on this.
Yeah.
You could skip the collect step, right?
Yeah. So no, actually, collect step is required because this is giving us another RDD.
Correct.
And therefore, if you want to process it locally, then we have to collect. If you don't want to process locally, if we are trying to save or we want to do other operation, but here we wanted to print the data locally.
So that collect is required.
Yes. Okay.
Sandeep, is it because on RDD we can use only take? I mean,
All right. What?
we are using collect. Is it because whenever we do that RDD, right? We can do like on the variable we can do it's like take and we can get the values.
Correct. Correct.
Are those is that the only operation we can do if we have only RDD value?
As in, come again, please. So
I
here,
mean,
let's say,
I mean to say line number 2 where RDD dot one RDD one, right? If I
yeah.
want to get a value, so I can do
Mhm.
RDD one dot take of 0 or 1.
That's right.
So is it like we cannot do for loop on the RDD one? We are using
Uh,
color.
Correct. That's correct. So
Okay.
since RDD is distributedly located, right? So we'll have to, if you want to apply a for loop or any other mechanism, you will have to bring it locally.
Okay.
All right. A question from Binta is, what is I.ProductIterator? I.ProductIterator essentially gives us the access to the values for this. Okay. So if we take a look at, say, for I in vals, and we say print ln I. Okay. So you can see this is a compact buffer. Okay, so let's just do product iterator and say I dot product iterator. All right. So it's a non-empty iterator. It basically gives you the access to the values. Okay, that's what it does.
In this example, where are vals?
Here you can see after collecting.
Dot collect. So what is the output of vals? Can you show?
Yeah, vals is this. You can just try. All right. So it's basically the resultant is a big array of tuples. This is one tuple. This is another tuple.
And the
And
first, yeah.
each of the tuple is, first one is your key on the basis of which we are grouping. And second one is the group of values. Okay. So this is another group and this is another group.
So what do you mean by compact buffer?
Yeah, compact buffer is an internal representation of an array, which is far more efficient than usual array. So it is that way.
So we can see the values of compact buffer also.
You can see that here it is showing 2, it is showing 4 and 6.
So first index and second index like that.
Right. So when we have to iterate over compact buffer, we have to use the product iterator to go over it. All right.
But
So we
this
get.
could.
So if you take a look at this one, we get this, and if we say product iterator, right? So you get the product iterator, and then you can iterate over the product, right? You could go over the product iterator by saying, let's say this is my ITR, okay? So now we could say for value k in the iterator, and we could print the value. Oh, sorry. Oh, I did a mistake. All right, let me just show you what it means. Great. So we are able to print say k here by iterating over it. All right. So you could take a look at the say vals, and all right. So we were able to print the values. Okay. So what does it mean by product iterator? That's generally asked. So whenever we are going through any iterable thing, we could always get the access to the entire object and then print the values. All right, that's what is going on here. All right, so
I was just wondering one thing over here. Because we are calling the collect function, can we not run into a memory overflow problem over here. If the data set is too long, and then if you have group by and then you do collect, will that not cause a memory overflow because you're getting the values from all the distributed RDDs to one local machine now?
Come again. So just a second. Just a second. I'm just trying to demonstrate this example. Let's say we have this kind of thing and we are saying product iterator. All right. So somebody was asked, this is what I was trying to explain to you, that let's say you want to iterate over the values of a tuple. So instead of using dot_1, dot_2, we can also iterate over the values using something called a product iterator. All right, that's what is going on here. So we are iterating over the values of tuple. It essentially internally converts it into like a list, and it lets you go over it. So if you want to go over the values of tuple, you could use the member variable called product iterator. All right, was able to explain, Binta? Okay, so this is what is going on. So what we are doing is, instead of saying I._1, I._2, we are using the product iterator to iterate over all the values. And this example makes it extremely clear. Yeah, now you can go ahead.
So Sandeep, RDD is not iterable, or so why we can't do the like Garisma asked, like why we are doing that collect first for doing the for loop. So
Okay,
what is
so
the reason behind this? It is not iterable, or
correct. So if we are iterating over RDD, then the whole purpose of distributed computing is lost. All right. So since the RDD's partitions could be on multiple machines, it's not necessary that the data is on your machine, right? So when you are iterating over RDD using a for loop for each loop and things like that, so the entire objective is lost. Therefore, it is better to just collect the data locally and do it. That's equivalent of the same thing. If you want to iterate over an RDD, essentially what you're looking for is that you want to get all of the data local and then run the for loop. And that's what collect and followed by a for loop does. Okay, so in a distributed fashion, when we are working with, say, Spark or anything, any of this kind of a code is kind of doesn't make sense, right? This is only for the presentation explanation purposes, that this is what's going on here, right? This is not something that we should be doing, like collecting the data locally or anything, right?
so if we do like two RDD cross operations, suppose I need some data from RDD1 and some data from RDD2, and I
Yes,
want to join or do some operation. That
yes.
time also I have to take it locally, or it will be work on the distributed fashion.
It will work on distributed fashion. As we discussed yesterday, there are functions like join, cross, and so on. It doesn't bring the data back to you. It creates result is the basically another RDD. It's only few things, like we call them actions, like reduce, like calling the reduce, or calling the take, calling the collect, that actually converts an RDD into a local value. All right.
Okay. So if we write some custom function also, suppose for cross join for two RDD, if I
Right.
writing that some custom function for some business logic, so
Right.
that time also it will not giving the data is locally. It will work on that same distributed.
Yes. If you are bringing data locally, there's something wrong. Okay.
Okay.
Okay. You must make sure that you don't use such functions like collect or take in a production scenario, because there is something seriously wrong if you're trying to bring data back from all the nodes to local machine and then sending it back. And that's what actually consumes most of the bandwidth, and it will suddenly your application will become like 1,000 times slower. Okay.
Okay, Simon. Thank you.
All right, good.
I just have a quick question over here. Would you say that most of the actions
Right.
gets the values to a local machine and you lose the distributed computing power?
Exactly. Yeah.
So you just have to call your action towards the end. That's the
Right.
final result.
Right.
All right, thank you.
All right. So the way you, if it is as much as possible, try to keep the actions towards the end, and so on. All right. A question from Sachin. Can you please explain the architecture Spark? I would suggest that you go over the discussion we had earlier. We have the studio recordings as well. So, or if you have pointed questions like some part of it, you can ask. All right. We are going to discuss how to run Spark on the cluster very soon. I think your queries related to running on the cluster will get cleared that time. Okay. So, all right. So I hope, Grishma, your question is now answered. So yes, if the data being used is huge, then this will cause an overflow. All right. Now, so
So Sandeep, is there alternative of it if it is memory overflow like in production, then
right,
what would be the alternate? So we have to tune it, or
you will have to look at look at all of the RDDs, look at your logic. Mostly, most of the errors that I've seen in past is because of not understanding the architecture. So we start using Spark for the namesake. Like we will parallelize the data and then we'll collect it. Then we'll load the data from HDFS, then we collect it, then we will do some for operation, and then again put it on Spark, right? And we would generally believe that magically Spark will make it really fast. No, because you are putting the data to Spark, then bring it back by using collect, and eventually you will end up with a bigger mess than actually normal SQL programs. All right. So we have to take a look at our function from top to bottom and take a look at it closely. Can we convert it into kind of map and reduce paradigm? Can we do it the way we do it in SQL instead of going over the for loop, right? We don't, in a database table, we don't go by row. We don't write like a for loop saying for I in the row do this and so on, right? Instead, we think in terms of how can we group by, how can we join, and so on. In the same way, you have to think the logic in Spark. So when we see the memory overflow, it's generally because we are trying to bring the data from the cluster to locally prematurely instead of results. If you want to bring the results, what you can do is you can use save as HDFS file that will save the data into HDFS. Save as text file will save the data in HDFS instead of bringing it back to you. All right. Was that your question, Sachin?
yes, yes. Thank
Okay, great. Great. Grishma, is your question answered?
Hi, sir. I got it, but my question is, how will be knowing if you are working on some data that it is so huge, and even the
Uh,
computation will be huge?
you will know, right? You can just do a count and then see the number of records, right?
Yes, but in general, we have to use the Spark logic. I mean, Spark programming means
Right,
RDD and
right,
collect
right.
happen
So,
on
so
in memory.
right. So Grishma's question is that first, we won't really know how big a data our software is going to run, right? So truthfully, you don't need to do that. You never need to know whether. So imagine that the let's say the max temperature program that we have written, it'll actually work perfectly fine even if the data is of gigabytes or terabytes. All right. As long so essentially if you are thinking the way instead of using collect, so avoid collect at every point because it doesn't make sense to have collect. Here we are using collect just for demonstration purposes, right? So in production environment, you can't really see the data, right? You will just submit your job and let it run, and so on. So you have to make sure that you don't use such kind of collect or take or things like that in production. All right. So whatever if you are using the standard MapReduce and using it in a nice fashion, the chances are that it doesn't matter how big is the data, right? Like, doesn't matter much if you are using a select query with where clause. We don't know how many records are going to be in the table. So in the same way, here also we don't need to know how many records are going to be in the table. All right. So, all right. Was I able to answer your question?
Sandeep, one more question. Where are the Spark logs?
Right. So Spark logs can be found in the conf logs, and if you are running on the cluster, you can find in the same place as your MapReduce log or any job logs, which is under yarn.
So
All right.
that will also show the memory out of leak or something.
Correct. Correct. The other thing is when you are launching a Spark application, there's something called, we'll talk about that when we talk about the Spark advanced operations. So there we will take a look at the UI, and then you will be able to diagnose where is my memory gone. All right. Great, great. So moving ahead. Now, in the same way, we can access the values, we can do group by, we can, right? So here we can do, right? So in the similar way, we have combined by key, just like we had an aggregator function, aggregate function earlier, which was an alternative to reduce. Here, combined by key is an alternative to reduce by key, where you have create combiner, merge value, and merge combiner. So you can define multiple functions to control the reduce. All right. So let's say we have okay. So here it gives us just like the earlier we had init value, then we had the merge the sequential operation, and then we had the merge operation. In the same way, we have the three things here. So create combiner, merge value, and merge combiner. All right. So we can discuss that. All right. Let's take a break for 10 minutes. All right. So the way we had learned earlier that we could, instead of reduce, we could use a more sophisticated function like aggregate. Similarly, we have combine by key instead of reduce by key, in which we get more control over how the initialization of the base value happen, as well as how the values are getting merged with the base value, and how each resultant of every partition is getting merged together. All right. So imagine that we have two partitions, 1, 2, 3. First, our create combiner, the function that we do will be called, and then the merge values will happen, and so on. All right. So you would generally not need it. You can always do the same thing by using the map function and so on. All right. So, but still, if you want to do that, you can take look at the combineByKey. Okay, the values from the resultant of each partition is getting merged using MC, that is your merge combiner, and values are getting merged using MV function, and the initial value is being created using CC. All right, so that's how it happened, and basically combineByKey is a more sophisticated version of reduceByKey. All right. I can safely skip it now. Sort by key, there is a function provided to you on an RDD based on sort by key. It basically sorts the data based on the key of the key value RDD. And you can specify things like how many partitions do you want in the outcome, and whether we want to go with ascending or descending. By default, it is ascending. And if you want the descending, you can say ascending equals false. All right. So that way you can use the sortByKey. All right. And now this is something different in case of key value pairs, right? On key value pairs, you can perform join operation. You can join two RDDs, RDD1 and RDD2. All right. Imagine that you have two RDDs, one having the key value pair like A1, B4, C5, and second one having A2, A3, and D7. If you want to join X and Y, so what does it mean by joining? It's essentially equi-join. We are finding the values for each key in the other one. So for A, all the keys that are matching A, these will be retained. Okay. Similarly, B will be B, since there is no corresponding value in the other RDD for B, there's no corresponding value for C. Therefore, B and C and D all will be dropped. Only A will be kept. Also, please notice that they will be combined together in the form of tuples. All right. So for A, these values have been combined, and the way when we are joining these two, like X and Y, what's happening is the value like 1 will be coupled with 2, 1 will be coupled with 3. Okay, so corresponding key is found in the other RDD, and all possible you say Cartesian product will be formed. This is basically equi-join. Similarly, we have something called leftOuterJoin. LeftOuterJoin means retain the value from left, all of the things from the left, and if there is no value found in the right hand side, put null over there instead of dropping. For example, we are saying X leftOuterJoin Y. What it means is all the values of the X will go in the output, like A and B has gone in the output, just that since the value in the right hand side is not found, therefore it is filled with none. All right. Now, so let's take a look at this kind of example. Let's say we have X, which is basically parallelizing this. It's a Python code. It's not a Scala code. We could just change it to Scala code. And when we say leftOuterJoin, what happens in this case? What will be the outcome? Quickly, if we are joining X and Y on leftOuterJoin, what will be the outcome? And this is the key. 1 and 2 is the key. 1 and 3 is the key. This is one RDD. This is another RDD. This is one record, key and value. This is another record, key and value, right? So when we say leftOuterJoin, okay, so 1 and 2 will be there, okay? So it'll be one Sandeep and one Ryan, while for 2 it'll be 2 Shravani and then none. Right? So one Sandeep and Ryan, one Sandeep, one Ryan, and 2 Shravani and none. Right? That's what is happening. So this is called leftOuterJoin. Similarly, we have rightOuterJoin. RightOuterJoin is basically just opposite of leftOuterJoin, in which the keys from the right is retained while the left hand side are dropped. Something of that sort. So when we are saying rightOuterJoin, we will get one Ryan and one Sandeep and 3 Giri and 3 none. Right? This is what is going to happen. All right. So
I didn't understand none. Where is coming none?
Right. So the way in SQLs, if the value is not found on the other side, you put none there. Right? So the Giri's 3 is not found on the right hand side, right? Left hand side, right?
Okay.
Therefore, all right. So that's how the outer joins work. So leftOuterJoin retains all the values of the left. If the corresponding value is not found on the right, it puts none. Similarly, rightOuterJoin retains all the values from the right, and if the value is not found on the left, it puts none there. All right. Now another function called cogroup. It's very often that we, just after joining on the same key, it's very often that we group the data together. So Spark has given you one more one more very useful function called cogroup. It basically combines the grouping and joining together. So it basically, for each key in itself or the other, it returns a resulting RDD that contains a tuple with a list of values for that key in itself and the other. So essentially, it's doing the joining as well as grouping. Imagine that we have A1, B4, and in the second RDD, we have A2 and A3. So when we are calling it co-group, it is going to first group and then join. So when we group this, it's going to be one element. And when we group this, it's going to be two element in the value. And when we join that, those will be brought together. So 1, 2, and 3 are brought together, right? So, and similarly here. So essentially, grouping followed by joining is what it means by co-group. All right. So, and of course, just like we had the count by values, we have here the count by key. So if you want to just find out the word counts, you can just call count by key and it'll give you the statistics, as in how many times each key has occurred. And now this is another interesting function. So we have a lookup by key. If you want to look up a particular record based on the key, you could use a function called lookup. We could have used filter, but filter will basically will be doing the same thing internally, but it'll take here. You have an upfront function called lookup. Internally, it's going to be using filter or something of that sort. All right. So it returns the list of value in the RDD for that key. This operation is done efficiently if the RDD has a known partition by only searching the partition that the key maps to. So it's going to essentially find all the values for a particular key. Okay, it's going to find all the values for a particular key. And I'm going to show you this. So let's say we have an RDD with list 1. Okay, I'm going to define tuples here, 1, comma. All right, so we're going to say 1, right? And then here again 1, and we're going to say 1 again. Okay, and say here we're going to say 2, right? 2, and we say 2. Okay, and we're going to call sc.parallelize just to create an RDD quickly. All right, so we have RDD that looks like this. We can just take a look at the first element if everything is good. Yes, it's good. So we can say RDD, and we can say lookup, and let's say we pass 1 here. So you can see it has given us 1 and 1 again, right? Both of them. If I say 2, it has given us 2 in that string. So this is what the lookup does. Lookup basically looks up based on the key. All right. Now, if you order the data based on the key, it'll suddenly become really fast. It'll become really fast because it keeps in the memory that it makes a note that, hey, this is a sorted key value pair. Therefore, it doesn't have to scan through all the partitions. It can quickly jump to a particular partition. So after sort by, the lookup becomes really fast. So it's kind of, you can think of that if we sort the data, if we have to look up something again and again in certain data, you could just sort it and then look it up. So these were some more operations on RDD. Using these, you can actually build a very sophisticated big data processing pipeline. All right. With this knowledge, whatever we have, you should be able to build a sophisticated um, pipeline of the operations. All right. Now I would like to continue to the next topic. All right. So we have covered the basic operation on the RDD. Now let's move on to next topic. It is called the advanced Spark programming. Uh, Basically, after these two, we will talk about how to run on the cluster, this one, and then we will talk about the data frames. Okay, sure. I'm going to be sharing these. All right. Great, great. So let's get started. All right. So far we have covered the basics of the operations on RDD. Now let's move on to a bit advanced operations. Now, other than transformations and action, there are multiple features which Spark provides you. One of them is persistence or caching. So what we have learned so far is the RDDs are lazily evaluated when we save data, or when we call take, or when we call collect, or when we call reduce, like action. Only then, only then something happens. Otherwise, it just keeps making notes, and then so that it can optimize the entire thing at a later point of time. So RDDs, that the one that we have seen so far, are lazily evaluated. All right. All right. So, okay. Right. So RDDs are not evaluated when you are just calling, say, sc.text file. It gets evaluated when you execute something. When you execute something, that essentially means that RDDs are lazily evaluated. All right, Hitendra. Okay. Second is RDDs and its dependencies are recomputed on an action. If you have two actions, we're calling two actions, then the entire cycle gets re-evaluated. We may wish to use the same RDD multiple times. We may wish to use same RDD multiple times. So every time we use it as part of the job, it's going to be again computed, right? So to avoid recomputation of RDD, we can actually cache it. The caching will remain only for that job, right? As long as your program is running, like the way we are running the console, it's actually a program running. Therefore, as long as we are running the console, like driver, then the program will continue to run there. Okay, so as long as we are running the console, the Spark driver is on, we are in the same session. Therefore, the caching will be used there. If we cache an RDD, it will be available there. But the moment we exit the console, whatever we have cached will be destroyed and dropped. Okay, so the RDD, if we are in a part of a big job, if we are calling the same RDD again and again, then it's better to just cache it instead of it being recomputed every time. That's why caching or persisting is required. A question from Raju is there any limit on number of copies of the same RDD can be stored in memory cache, or maximum number of different RDDs that can be stored in memory cache? So we'll talk about the memory very soon. So there is an upper limit on the memory, and you can't go beyond that. Afterwards, you will not be able to cache anything. Okay, when we are defining operations like map this, flat map this, or filter this, we are defining just the operations. Okay, they don't take much of a code. It's just few bytes. Okay, just we are defining how to compute something. It is not really loading the data, right? When we say action, only then something happens, right? If a node that has data persisted on it fails, let's say here we are saying that if a particular RDD is being used multiple times, load it in the load, do the persistence or do the caching. Persisting and caching is used very interchangeably. Okay, so if a node on which, let's say we did the persist, what's going to happen internally is it's going to keep this RDD's partitions in the memory available to everybody else. But if a particular machine on which some partitions were loaded into the memory, if that fails, then it will be recomputed because Spark knows how we computed a particular RDD, right? It knows the entire RDD graph, that RDD1 led to RDD2, RDD2 led to RDD3, and so on. So Spark knows the entire graph, and hence any RDD that fails, any persistence or any caching that fails will be recovered in the same way, the way it was created. So we can also replicate our data if, let's say, that a particular RDD that is being cached in the memory and we want it to be readily available to hundreds of operations parallelly. So we can actually replicate even the in-memory caching. All right. So those are the advantages of the persistence or caching on RDD. So this is an additional step in order to optimize your process. All right. So let's say we have an RDD like nums, which has 100,000 records and it has 50 partitions. And we are computing the partitions. We are computing the summation of each partition. Remember, map partitions function. And then we are increasing the value by 1. And then we are basically on this resultant, we are incrementing by 1 and so on. So you can see that the partition 1 is computed by this kind of complex operation. And this partition 1, if this is being used very frequently, so it's better to cache it instead of recompute it. So we could say partitions 1, whatever RDD that is going to be reused very often, like this RDD being looked up very often, or the RDD being joined very often. So it's better to just persist it. Okay, so it's better to just persist it. And in order to find out whether an RDD is persisted or not, we can just take a look at the storage label. All right, storage label generally tells you clearly that what is the meaning of, what is the current state of a particular RDD. All right, so this is basically what persist does. In order to unpersist an RDD, we can use unpersist. Please note that generally when we say persist, persist generally means saving into the hard disk, right? Saving into the disk or saving into a storage. But here, it's not that way. Persist means compute the RDD. Persist means compute the RDD and load it in the memory or or in somewhere so that it doesn't have to be recomputed. The RDD doesn't have to be recomputed because RDD is nothing but graph, and RDD doesn't have data unless explicitly called, right? So in order to convert that RDD from a graph of node into a value that could be loaded, we need to do persist. Okay. So again, question is whether it is going to be in the memory or in the hard disk. Let's take a look. All right. So let's take a look. That is controlled by something called storage label. That is controlled by something called storage label. So there are shortcuts to the store. We can basically define our own storage level object And in the storage level object, we could configure that we want it in the memory or in the disk, which kind of serialization do we want, and so on. And then we can pass that storage level object to our function persist. For most common operations, the storage label has already defined these flags like memory and disk. So when we call partition1.persist using storage label dot memory and disk, what will happen is it will keep this in the memory, right? It will keep this in memory as well as in the disk. If the data is not fitting in the memory, it is going to keep it in the disk. All right. So at any point of time, you can use this get storage label, and that will give you the idea that what's going on with the persistence of any RDD. So similarly, we have other shortcuts like storage label dot memory and disk and so on. Now, so this function rdd.persist storage label, rdd.persist storage label. Okay. All right. A question from Grishma is that what happens when a disk where one partition was residing fails, as I just discussed here. If you see, all right. If a node that had the data persist on it, Spark will recompute the lost partition, right? It'll recompute the lost partition. All right, because Spark knows that how to compute an RDD, right? That's what we define as part of graph. So it has computed once, and therefore it'll do this again. Now, let's talk about a bit more about storage. I'll answer your questions as after this. Okay, so basically, the persist function takes an object of storage label, and what does this storage label represent? So persist function on an RDD has takes an argument of storage label. Storage label can be defined like this. We could create an instance. We could create an instance of storage label passing these flags. The first one is whether to use disk or not. Second one is whether to use memory or Second one is whether to use memory or not. Third one is use of heap. Okay, this is something specific to Java. We'll talk about that later. So if you want both, if you want to use disk as well as memory, you could pass this as true and this is true. All right. And if you want to use of the heap memory, then you could use this one as true. Here we are saying false. And whether to store the object in the deserialized format or as is, then we could use this fourth flag. And last flag is a number. Last argument to this is a number that represents how many copies of this cache do you want in the network. All right. Generally, one replication is good enough, but if you are expecting just too much of load on this RDD, too many users trying to access this particular RDD, then you can increase the replication. Or you expect that there could be failure parallelly in the network that we don't want to tolerate at all. In that case, you can increase the replication factor. So we could call the partition.persist with this object by passing the various flag. So first one is use disk, second one is whether to use memory or not, and third one is use of the heap memory. In Java, you have on the heap memory as well as of the heap memory. Okay, and fourth one is deserialize, whether to keep the objects in the deserialized format or not. And last one, yeah.
This means if it is in HDFS, we can say.
Right.
And deserialize means?
Right. So there are two ways to save the data. One is using the Java's default way of storing the object, or using a proper serializer to save the data. So in when you are converting an object into a sequence of bytes, you can use an external serializer that is more efficient than the usual Java's one. Okay. All
Okay.
right. Yeah.
Serialization would be like a compressed form of the original, right?
Serialized format will not be a compressed form. Serialized format will be, let's say you have an object in the memory, correct? What
Mhm.
is an object in the memory? Object in the memory is bunch of variables pointing to some values, right?
Okay.
Now, in the memory, everything is good, everything is happy because you have the address of the RAM, you have the pointer to the various locations. But if you're moving it from one, if you want to save this on the disk, right? These addresses do not mean anything. So we'll have to come up with our own format such that these values can be stored. Now, to
Okay.
come up with that format, one way is the Java's default way of saving the objects, right? That is little more inefficient. While there is another one, there are many others which basically take the object and convert it into a sequence of byte. Like JSON is one form of serialization. You can convert any object into JSON or XML, right? Those are all called serialized formats. XML is
Alright.
far more slower. Similarly, JSON is far more slower, and so on.
So
Okay.
there's nothing to do with compression. Like it's
Yeah,
nothing to do with compression. Alright.
that's right. That's right. Okay, a question from Vinda is of the use of the heap memory. So in Java, you have you have the heap allocated for normal works, and sometimes you may want to use extra values outside. So that's where you use the of the heap. This is very particularly for one particular data storage, and this off the heap does not make much sense in the normal settings. All right. So you would not need to actually tweak the third variable at all. All right. So instead of every time you creating the object that, hey, I want only the memory, disk, memory and the disk and so on, there are many inbuilt shortcuts. So we could simply say storage label dot memory only. Now in this case, what happens is it'll not parse the if it could it'll try to cache or persist the data in the memory. If it fails, then it will basically recompute the partition every time it is calling, right? So so right, so under the hood, the memory only is nothing but a shortcut to defining the storage label, and this is how it looks like. All right. Now similarly, we have memory and disk. In that case, use of the memory. So all right, a question from Bintao is serialize equals to index. Not really. Converting an object into sequence of bytes, right? So serialize is something a little harder to describe. So when we think about the memory in the computer, every location has an address to it, right? So one value in the memory could point to another address and so on. So generally, what are the objects? Objects are nothing but composites of multiple values together, right? These are complex structures in which the first. So how should I let me? So generally, let's say you have customer object, right? Customer, the way you define is it has name, it has, so let's say class customer, and it has name, and it has the address and so on, right? So this is one object. Now this object internally in the RAM, when things are in the RAM, it looks like this. Okay, this is a little bit more, under the hood. Okay, so what we have is, let's say there is a customer. This customer will be represented in the memory like this. Okay, this is the address to the customer. Customer has a pointer to the name and a pointer. This is the name of the customer, and let's say customer's name is SG. Okay, and the address is, say, someplace. Okay, so this is basically, it has, so this is our customer object. So this is our customer object. All right, this has one pointer pointing to the name and other pointer pointing to the address. This is how object is there in the memory. Now, here we are happy that this memory in the computer has the good address, right? This is some 0 address, this is 1, this is 2, this is 3, this is 4. Like, then another object comes, it will be here somewhere, and there is an address that we know. Okay, so this is how the data looks like in the RAM. In the RAM, the object is a complex form like this, right? So, but in the disk, we don't have addresses, so we can't really have the pointers. So that's where we come up with these formats like JSON, right? We come up with the formats like JSON, where we could convert any complex object into a string. So our customer object will look like this. Our customer object will look like this. In case of JSON, curly bracket, and here, let's say this is the name. This is the name colon the actual name as comma. Here the address colon, and this is capital A. So this is sequence of byte that it has created. This is called JSON format. So this is one form of serialization. Now, if we have this kind of serialization, we can recreate the object, even though when we recreate the object, the address could be somewhere else. Okay, so this can be recreated. This object can be recreated, transferred, or saved onto the disk in this string format. All right, so converting a complex object having the addresses and things like that into a sequence of bytes or sequence of characters is called serialization. All right, so that's what is serialization. Minta, does it make sense? So we could use different storage labels, and instead of you creating every time the storage label and calling it, you could use the shortcuts like storage label.memory only, which internally does not use disk, uses only the memory. Is rest of the flags remain same. By default, it is deserialized and uses of the heap. All right. So this one stores RDD as deserialized Java object in JVM. If the RDD does not fit in the memory, some partitions will not be cached and will be recomputed on the fly each time they are needed. All right, this is the default label. If we are using memory and disk, then these two flags will be on: use disk, use memory. Essentially, this is what is happening under the hood. These are just shortcuts to that object creation. All right, so either we could create the storage label and then persist, or we could just use the storage label dot these shortcuts instead of creating the object. So memory and disk stores RDD as deserialized objects in the JVM. If the RDD does not fit in the memory, it stores the partitions on the disk that are not fitting in the memory and read them from the disk whenever they are needed. All right, then we have memory only with serialization and so on. So these shortcuts basically tweak the basic one. So this one stores RDD as serialized Java object such that there is 1 byte array per partition. This is generally more space efficient than deserialized object, specifically when you are using fast serializer, but they are more CPU intensive to read. This is right. So similar to the memory and disk serialize, but with the serialization on. So when you use serialization, your disk storage is optimized, because generally these serialization formats, there are many serialization formats, they are quite space efficient, and also they are better than the Java's default way of storing objects. All right. So similarly, we have disk only, in which there is no use of memory and so on. And this is not generally appreciated um, because if you do disk only, every time you're going to call this RDD, it's going to read the data from the disk, which could be as fast as recomputing the RDD again. All right. And then further, we could also put _1, _2, and so on to control the number of replicated copies. All right. So there is something called off the heap, which is an experimental flag, and it was used only for Tachyon. Tachyon has some optimizer which let you store the data in the off the heap solution, right? So there is a heap memory in Java, and there is off the heap memory in Java, which you could use. That's the only thing. And this is an experimenter. There's not much of a detail provided by Spark on this. Now, question is which storage level to use? If the RDD is comfortably fitting in the memory, then use memory only. If not, try memory only with serialization. This way, in case memory it is not fitting in the memory, it'll be recomputed. All right. Don't persist to the disk unless the computation is really expensive, because reading from the disk takes a long time. So for fast fault recovery, in case you want to recover really quickly in case something fails, use the replicated. Now, lay out the data to minimize the data transfer. That's called partitioning. All right. So that was pretty much with respect to the persistence. So we could actually do a couple of examples here. All right. Let me just go back here. All right. Yeah. Let's try to cache this RDD. All right. So we have, say, created. All right. Let me just start again. All right, so you can see that there are 50 partitions and each partition is having some values. Okay, now this partition is every time you're going to do collect, it's going to execute the entire process. All right, so if you want to make it really fast, we could just use the partition1.persist. Okay, this will make it extremely fast. All right, this will make it extremely fast further. And if you want to unpersist, we could just use unpersist here. All right. And then we could also create the storage label like this. So we will have to import the storage label. Where is that importing the storage label? All right, here. All right, and then okay, so that this is what is going on under the hood, and then we can use this particular storage label. All right. So now if we use the partition1.collect, it's going to quickly get the data from the cache. All right. So this is what is happening under the hood. Now there are quite a few questions on the RDD. Okay, so let me just go back to your question. Question from Bintao. How does iterator work here? Which iterator are we talking about? You mean this one? The one which we did just now? Let me just show you the history. Okay, so we did things from here, right? We did things from here. All right. So let me just describe what this code does. All right, I'm just copying this. All right, great. Now, see, we have, let's say, a partition like this. We have an RDD like this with 50 partitions. Then we are defining a function called mysum. What mysum does is it takes an iterator as argument, right? Since remember our map partition example, whereby we took a function that takes an iterator. So since it's going to give the whole partition to your function, so it won't give the whole partition like an array. Instead, it'll give you a pointer, a cursor, a way to iterate over the records. Otherwise, if it gives you the entire partition as an array, the memory overflow might occur. All right. So that's what it is. That's why we are consuming an iterator as well as we are giving out another iterator. All right. So here, what we are trying to do is we're just trying to pick. What we are trying to do is we created a huge RDD, then we operated on a partition basis. We added all the partitions on there are 50 partitions in this RDD. And for each partition, we are summing up the values. We are summing up the values. Okay. And then we are incrementing some value on each partition. The objective is to make a little bit more complex function. All right. And then we are doing the collect, and that's all. So I hope this example is clear. All we are trying to do is do a little bit more complex operation in order to reach to partition 1. All right. Now, question from Bintao is it a data type? Yeah, iterator is an object. Iterator is a class or data type. All right. All right. A question was, what is Tachyon? Tachyon is a file system, which is called something else right now, and so on. Okay. So toIterator converts an array into an iterator. All right. Great. So moving ahead, did I miss any questions so far? I think most of your questions have been answered. If there is something not answered, please feel free to ask. All right. So basically, this is how you could persist. And now,
Sandeep, I have a question. So can you go back to that code, this Rajan?
Okay. Hey, Rajan. Yeah, go ahead. Okay. You mean this code? Yeah.
Yes. So
all right.
The first function that mysum that you have is basically
yes,
returning on each partition, it's returning the sum, right?
Correct.
And it's an iterator that you are giving.
Yeah.
So then the second one that you are doing map partition and passing mysum. So is it just taking a sum within the partition and incrementing by 1?
Yes. So first we are computing the sum of each partitions.
Okay.
So this one has 50 partitions, right? So
Okay.
the result of this one, result of say this one will be an RDD having 50 values.
Okay. But it's just sum at this point,
Yeah.
right? Because that will only have the count one value.
Yes. So this one, the nums, right? It has 50 partitions and has how many values? 100,000 values. The original RDD has 100,000 values distributed over 50 partitions.
Okay.
And at this stage, what we are doing is we are computing the sum of each of these 50 partitions.
Okay, let's say that after 93, you put partition dot collect and print that. It will only print 50 values at that point, or?
Yes, you are right. So let me just show you this part. So we have done this part, and partitions dot collect, or say partition dot count, right? So how many values are there? 50, right? Similarly,
Okay.
We could say collect, and you get these 50 values. All right. These are the sum of each of the partitions. So you can see in the first one, since there are 50 values starting from 1 till 50, the summation is this much. So this is n into n plus 1 by 2. So 50 partitions, meaning this one will have around how many values? Twice of this one, 2000 values. So summation of 2000 values is this much.
Okay.
Right?
Sandeep, I have a question over here.
Yes. Yes.
My question is, in order to speed up the operation, if you
Yes.
would persist partitions instead of partition 1, your speed up, the time required would tremendously increase.
Right.
So instead
So,
of persisting partitions 1 dot persist, you should have done partition dot persist.
right. So I'll tell you. So what I wanted to demonstrate is, let's say, okay. So here the objective was this. We wanted to create a complex RDD which has multiple operations. First operation was map partitions, other was map, and so on. So this is a result of a map, and before that map partitions, and before that parallelize, right? So to compute this, these operations need to go through. Now, every time we want to use partition 1, say partition 1 dot take to, partition 1 dot lookup, and so on, every time we want to use this, we are going to go through these operations. So instead of doing that, a preferred way is to do a persist on this partition 1. So whichever partition is taking too much time to compute, every time you are going to say partition 1 dot take 2, take 3, and so on, is going to go through the entire loop. Therefore, it makes sense to persist if this partition is going to be reused multiple times. I'll take a case, bigger use case. All right.
Correct. No, the reason I was saying we should have persisted partitions is because we just want to do an addition of 1 to the result of the total sum.
Right.
In order to go back to the memory again and again, instead if we would have cached it, it would be a faster operation.
Correct. So basically what you are saying is that since partitions is being used again, therefore it makes sense to do the partition, do the persist.
For partitions dot persist instead of partition 1 dot persist.
Right. So here I wanted to demonstrate a little bit different case. I mean, further to what your assumption was. So in the same way, I wanted to show that partition 1 is something that's going to be reused multiple times. Therefore, I want to persist this. All right. So wherever in your code you observe that, okay, you are again and again joining a particular partition and it's taking a lot of time to do that, or you know that it's a complex process, then you should persist that particular RDD which is being reused again and again by various steps. Okay. A question from Alok is, sometimes we will get task not serialize? What is the reason behind it? Good question. Good question. Sometimes some of the objects are impossible to serialize. For example, the connection object in the database, right? So if you have the connection to the database, connection object to the database, then if you say serialize, meaning save it to the disk, and tomorrow you deserialize, right? So it doesn't make sense because connection means a live connection. So not every object by default is serializable. So if you are creating your own class X, you may want to implement serialization, implements serializable. Okay, so you will have to implement serializable. This just signals the whole Java ecosystem that this class is okay to be kept in the disk. All right. Similarly, here
And
also.
Persist means it is persisted into the disk.
So as we said that it can be persisted anywhere based on the flags that you pass. All right, like the one which we talked about here. So you can pass, you can create a storage level object by setting these flags. If you set the first flag as true, that means you want to use the disk. If you set second flag as true, then you want to use memory, and so on. All right. So basically, this persist is the one that takes a storage level object, right? Instead of passing these 4 flags to the persist here, you pass this object to the persist. All right. Does it make sense to you?
Yeah, yeah.
All right. A question from Rajan is, do we need to collect before persist? Not really. If you collect, that means you have brought the RDD to the local machine, while we want to persist the partition wherever they are in the network. A question from Grishma is, if we don't use persist, will what will happen to the partition? Okay, so if let's say we don't use the persist, can you rephrase, Grishma? Is that did I understand your question correctly? A question from Grishma is that if we don't use persist, what will happen to the partition? Partition will remain, every time you call the partition, the whole partition will be recomputed. Nothing will be cached.
I mean to say, if we don't persist the partition,
Mm-hmm.
and if I'm on a session and I'm working on some RDD, and if I
Mm-hmm.
don't persist the partition, and if I log out, what will happen to the partition? So it will be in the disk.
Okay, so as soon as your job ends, if I let's say exit from the shell, if I exit from this shell, whatever I have persisted would be deleted. So
Okay.
as long as your process or job remains active, it will be there. As soon as you exit, all the persistence will be deleted.
Okay.
All right. So you cannot use a persisted partition across the jobs.
I got it. So what is the point of using the persist then?
Right. So in the same job, there, let's say you are using a lookup again and again on the same RDD, or you are joining the same RDD multiple times with different partitions, right? Or you have a long running job, which you have a long running job, and there is a newer data you're reading from the disk and joining it with the existing one. Then you would like to cache it. All right.
So if I don't persist it, so it will be lost, or it will be in the disk? It will be in the disk, right?
Which one?
If a particular partition, if I don't persist it.
Right.
So what will happen to that partition? I mean, within
So,
the
so
lifespan
yeah,
after the job.
yeah. So unlike the word persist in the true sense, here persist is just caching. Okay, the caching means instead of recomputing the entire partition from the beginning, it it is kept in the memory. So even if you don't persist, everything will work perfectly fine. Persist is only used for little bit of speed up the process.
Okay, I got it.
All right.
Thank you.
Okay. All right. A question from Vinta is that how to use help to get explanation about some command and syntax in Scala, such as help iterator. Okay. Okay. So that I need to yet figure out, and I'm not sure how to say. Does it say help here like this? So help and say iterator. Does it say anything? There is no such thing. All right. I'll have to figure this out. Last time I figured it out, I just forgot how to do that. All right, great. A question from Raju is, for this statement partition 1.persist, what are the default parameter values of for storage, right? So, yeah. So, yeah, the default parameters are these. I'll show you. The default parameters for, you can see, let me go back. At any point of time, if you want to just find out what's the state of, let's say, partition 1, let's say partition 1, partitions 1 dot persist, right? Let's say this is what we did. Okay, so what does it say? It says it's already persisted, cannot change the storage label. So we could say unpersist. Okay, and now we can repersist it. Then we can check what is the storage label. Okay, so you can see first is false. Okay, first is false. What does it mean by first? All right. So use disk is false by default. Use memory is true. Use memory is true. Okay. And so on. So you can see these are the default values. So at any point of time, you can just say get storage label and so on. All right. Great. Should we move on? All right. So this was a quick overview of how to use the persistence. Persistence is basically for optimizing or making our process faster. Now, the another knob that you can tweak in order to make your process further faster is called data partitioning. Is called data partitioning, meaning what we do is we lay out the data in order to minimize the transfer. We lay out the data such that our transfer is minimized. I'll take a practical example of this. So it's not helpful if you need to scan the data set only once. It's helpful when the data set is reused multiple times in key-oriented operations, just like we are doing lookup or join, or if we are looking up or joining or doing something based on the key, then data partitioning makes a lot of sense. It's available for key-value RDDs, and it causes the system to group elements based on the key. Spark does not give explicit control which partition will have which key or which worker node will have which key. All right, it lets the program control ensure which set of key will appear together. It's based on some hash value, or you could use the range sort. So essentially, the data partitioning means in what order your data would appear in the RDD, which keys would appear together in the same partition. All right, what kind of keys would appear together in the same RDD. Now, let's take a practical case. Imagine that you have a website. Imagine that you have a website, and this website has the user data and the events. Now, so what you want to do is, let's say you have a website in which there are users who subscribe to various topics. They get an email saying that, hey, these are the things that you may want to you would be interested in. And also it keeps track of the history of the users. So let's say you want to find out how many users are visiting the links that were not one of their subscribed topics. Let's say you want to find out which users or how many users are visiting the various topics which they did not subscribe to. All right, let's say that is the problem statement. And what we have as a database or files, let's say we have two RDDs. One is user data, other is events. The user data has key and value. Key is user ID and the value is the topic info, user subscription topic info. And the events which are happening right away is in the form of which user ID is visiting which link. All right. So what we need to do is, so these events are periodically coming while the subscriptions are static. So we have the subscriptions RDD, which is kind of static, and these events we are loading periodically from somewhere based on last 10 minutes of users' behavior. And every time what we do is we join the users data with the events. We join the users data with the events, right? On what basis? User ID basis. Okay, and then we check that was this link part of the subscription? Okay, imagine that this is nothing but a list of topics here, and this link info is nothing but topic name. So what we'll do is every time we'll join these two events and user data on the basis of user ID, and then check, was this particular link part of the subscription or not? That's what we would be doing. So periodically we combine user data with last 5 minutes events. So what will happen is, if we join such data, there will be a lot of shuffling. So for every user, we'll try to find out which are the events and so on. So there will be a lot of shuffling when we are trying to join the data, right? Therefore, there'll be a lot of network communication and it'll be inefficient. So to make it more efficient, so here is an example of the code. Let's walk the code from the top to bottom. So here we are initializing this Spark context. This is something which we get by default. Then we have, say, user data, which is we are loading from some file in this form. It has user ID, user info, two objects. And we are persisting this user data because it is relatively static and we don't want to load every time from the HDFS. Then we are defining a function called process new logs. We are defining a function called process new logs. And here we are passing the new file. So we are going to call this function every time with the new file of the events. So we are loading the events from that file, okay, and joining the events with our user data. Even though we have persisted the user data, so it will be a little faster because we don't have to load every time from the HDFS. Every time we call this function called process new logs, is going to join the new events with our user data, right? And once we have joined the data, then we do the filter such that we are basically saying, when we are saying filter, we are saying for these records, find out if the user info dot topics contain the link info dot topics, right? So we are only filtering those cases and we are just counting them. Okay, count is an action, so this will execute the entire process. This count will execute filter, filter will execute join, join will execute so the sequence of things is going to be basically based on the dependency graph. All right, so count depends on the filter, filter depends on the join, join depends on the sequence file loading, and so on. All right, so and this way. So here a question is from Binta, what is this case here? Remember that we did the matching of the objects? That's what is happening here. In case the objects don't look like this, then it will skip these records.
So Sandeep, events and join and office are different RDD.
Events and
Join.
Events and join. Yeah, these are different RDD. This is a different RDD. This is a different RDD, and this is a different RDD.
Okay.
All right. So this events RDD, we are recreating every time the function process new logs is called. All right.
Off-topic list is visits are also in RDD.
Which one? Off topic? Yeah, this one is also an RDD. So not an RDD, sorry, because we are calling the counts here. That means till here everything was an RDD. The moment we called a count, it would return the numbers. This is the local value. You see, since till here it was an RDD. Okay, let me just break it down. All right, so from here till here, this was an RDD, and since we called a count on top of it, therefore it converted that RDD into a local value because count is an action. All right, a question.
Sandeep, I did not get the case statement here.
Okay. Yeah, so here we could have actually just ignored this part, right? I'll explain to you. So case is basically for specifically matching, right? So we are assuming that, let me just copy everything. All right, so let me just go over it again. This is clear, this is not required because this is something that is created by the Spark shell for us. In the Spark application, this is something which we'll have to create. We'll talk about it in the next session. Now here we are saying sc.sequence file. If you are loading the data, binary data from a Hadoop file, we generally use sc.sequence file, right? Sequence file means a file which is in the format of, which is a humongous file and is basically binary key and value. All right, so you could save your objects in the form of sequence file, right? So we have in the initial of the program, when our program is starting, what we're doing is we are loading this binary data and converting that into user ID and user info. All right, so this RDD is going to be a key value RDD where the key is user ID, this is an object, and value is user info. Okay.
So Sandeep, are you saying that in the the Hadoop file system, the binary file will have a user ID followed by some stream of bytes?
That's right.
The information. It's actually stored that way.
Yes. Yes.
Okay. It's separated by comma. Is that what you're saying?
No. It just we are just defining the data type here.
Okay.
The way we define the data type elsewhere, here we are telling that while loading my data, consider the key as user ID type and value as user info type. All right. So sc.sequence file accepts the objects in this format, accepts the syntax in this format, whereby it wants you to define the data type, because the raw data could be containing anything, and it wouldn't know how to convert the raw data into objects. All right. Next is all right. Next we are doing is here there's going to be a full path. Right now we don't have full path here. Once we are done with that, we are calling the process new logs. This one is going to basically process these new logs that have come in last 10 minutes. Okay. And again, this log file also contains the data in the key value format, where the key is user ID and the values data type is link info. These are the three objects we have. Okay. Now, so these are the events. So we are basically joining these events every time this process new logs is called, and then we are filtering it. Okay, so we are filtering it here. Instead of we writing the logic that check if the data is in the format of key and value, we are using this pattern matching of Scala. Remember, we used the case matching earlier. Similarly, we are using the case matching here. All right, so we could actually use the something like this. We could have said, okay, if we are not using this model, this is how it'll look like. All right, I'll just explain what it means. So let's say we don't want to go this route. Well, we want to define our own function. We want to define our function that takes a tuple containing these values. This is our tuple. Tuples data type are these three, and we are defining our function like this. Okay, so we are saying return this. Okay, and then okay, so we could just say, all right, so something of this sort. And here it is supposed to be brackets. So there's a bit wrong in it. So yeah. All right, so this is what is going on here, and yeah. So essentially here, what will happen is when we are calling this function here, if some of the records are not in this tuple format, then it'll throw an error. For those kind of scenarios, we use the case class. For those kind of scenarios, we use the case class. What case class does is this syntax will be executed. This particular logic will be returned only if the input data is matching this data type. In case it's not a tuple, then it will be completely ignored and it will move to the next one.
Sandeep, I did not get actually this case.
Okay.
Why
Right.
we have
Right.
a user ID and user.
Yeah. So if I'll just show you, remember our case statement earlier? Where did we do that? In the case of our GitHub repository. So, all right. So here, this is where we did the case statement. And right, this is basically the pattern matching. So remember, we did the case, we did notification match this, and then we did the case. Right? So we did that. If this is matching with this data type, then do this. All right. That's what is happening under the hood. So this is what is going on. We'll actually take a proper example in the next session. The same example we'll try to execute and understand what's going on in the stepwise fashion. All right.
So here we are comparing if it's not equal, right? Because we have negation.
Yes. So here, what we are saying is, if our data type here, if the data type of this RDD is for every record, so whatever logic you pass in here, they're going to be bracket here. So
I don't know where are we getting that link info from?
yeah, so link, yeah, so I'll tell you. So what does our user data has? User data, what does it have? User data
It
is,
has the data from the HDFS in key value.
yeah, right. So it's basically made up of tuples like this, right?
Yes, correct.
This is user ID 1, user info 1, user ID 2, user info 2, and so on, right?
Correct.
Correct. Now moving ahead, this one events looks like what? User ID and link info. All right, in the same fashion. So we could just represent it in the same way. Okay, so user ID 1, link info 1, and right, and then we say user ID, link info 2, and user ID 2, and so on, right? There could be many such. This one is little bigger, a huge data. This one is a smaller data because these are 10 minutes events. All right. The moment we join these, when we join these user data dot join and say events, what happens? The result will be
Oh, all
equal to.
three.
So here it'll basically create a tuple user ID and then further user info, comma, link info, right? So this way we will get this kind of a tuple, right? So resultant of this is going to look like this. All right. So if we have user ID 2, the value will be another tuple containing the value 2 and so on, right? So this is the data type of result, right? Now this is how it'll look. Now what will happen is here when we are calling a filter on this, so this will be the filter will be applied on this object, correct?
Correct.
So that's what we are comparing. If the data type of the values is matching this, only then this case will be executed. It's like basically comparing whether some object is missing, some object is none, and so on, right? So that all of the logic of putting the checks whether user ID is not null, user info is not null, and so on, instead of we doing it, we are letting the case match the data type of each one and then execute our logic. So case is little tricky. We will go ahead with, we will actually try to show you more use cases like this. One we talked about here where we were matching the notification with the case class. All right. So that's what is happening here. And yeah. So this is the case class is generally a new concept in Scala. And that's kind of the most different concept than any other languages. And this is exactly done because in Java we always ended up comparing objects, that if object is of type this, then do this. And to avoid that casting and comparison, the case class or the case syntax, not case class, case syntax was included. It's not the switch in case. All right, so that's pretty much for today. We will continue from here next week. All right, those 4 things that I have given you in the links, please follow those and please finish those. That will be very useful. I have created an exercise for binary files. Bintao, remember our discussion from last time? The binary files, how to load them and process that. I have written entire code. Please take a look at that. If you have any doubt, let me know. All right. So thank you very much. I look forward to see you next week. Bye-bye. Have a good day.